Hey guys, welcome to our channel. So, I said I wasn't going to get anything else out today, but then, as I was uploading this, I realized that I had made a glaring omission. The beauty of it is I'm not dead in the water, I can go back and fix that omission. So, let's do that. So, it was back, we got to go back to our numerological numbers. All right, we got to go back to our numbers. And you had playing change to plays. He fell off twice. You cross off play because it's a like. You're left with INGS. And then he came down twice. We turned that to numerological numbers before. And we'd been running them in groups of four because that's what the pattern I saw, and they nicely went through. But I saw something else, and in a previous, in our Star Wars decode, I had used atomic numbers for gold and silver. And it suddenly dawned on me that I had a whole list of atomic numbers sitting here. So I decided to run those, and 9-5 going forwards ends up being Americium, 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 Americium. It was discovered in 1944 by Glenn Seaborg and colleagues. Americium is named for America, where it was first made. We've had it before, by the way, in other searches, letter searches actually, but it's a silvery, shiny radioactive metal. It's commonly used in smoke alarms, but has few other uses. It has the potential to be used in spacecraft batteries in the future. Currently plutonium is used, but availability is poor, so alternatives are being considered. It is of interest as part of the decay sequence that occurs in nuclear power production. It's toxic due to its radioactivity. So that's 9-5. 7-1 going forward then. You end up with lutetium. And lutetium was discovered in 1907. Georges Urbain in Paris, France, and independently by Charles James in New Hampshire, USA. So it was discovered by two people independently in 1907. It's a silvery white, hard, dense metal. Lutetium is little used outside research, so they say. One of its few commercial uses is as a catalyst for cracking hydrocarbons in oil refineries. And it has low toxicity. So then you have 8-5 twice, but I did a little something different with that because 8-5 is astatine. Astatine. And it was discovered in 1940 by Dale R. Corson, Kenneth Ross McKenzie, and Emilio Sergi. Segre? The name comes from Greek. It doesn't matter what the name comes from. You can read about that, guys. It's unstable and reactive nature of the element. The image is based on the radiation hazard symbol. And reflects the unstable and reactive nature of the element. All right, astatine is dangerous radioactive element. There are currently no uses for astatine outside of research, they say. The half-life of the most stable isotope is only 8 hours, so only tiny amounts have ever been produced. This is for uses. Mass spectrometer has been used to confirm that astatine behaves chemically like other halogens particularly iodine. And it's toxic due to its radioactivity. All right. So then I went ahead and took 88 because that's still coming forward. You have 88 and 55. If you then you get two more. So 88 is radium, and it was discovered in 1898 by Pierre and Marie Curie. Name was derived from Latin radius, meaning ray. And appearance, it's a soft, shiny, and silvery radioactive metal. Radium has few uses because it's so highly radioactive. Radium-223 is sometimes used to treat prostate cancer. Oh, nice. And has spread to the bones because the bones contain calcium, and radium is in the same group as calcium. It can be used to target cancerous bone cells. It gives off alpha particles that kill the cancerous cells. Yeah, and you apparently. Radium used to be radium used to be used in luminous paints, for example, in clock and watch dials, although the alpha rays could not pass through the glass or metal of the watch casing. It is now considered to be too hazardous to be used in this way. And it's toxic and radioactive. All right. Then you have 55, which ends up, we're still going forward, ends up being caesium. And it was discovered in 1860 by Gustav Kirchhoff and Robert Bunsen. It's a full. The name is derived from its flame color, apparently, meaning blue sky, and derived from its flame color. Caesium is a soft, gold-colored metal that is quickly attacked by air and reacts explosively in water. The most common use for caesium, Caesium, compounds is as a drilling fluid. They are also used to make special optical glass as a catalyst promoter in vacuum tubes and in radiation monitoring equipment. One of its most important uses is in the caesium clock, atomic clock. These clocks are virtual part of the internet and mobile phone networks. Internet and mobile phone networks, I assume, is what they mean. As well as global positioning systems, GPS. They give the standard measure of time, the electron resistance frequency of the caesium atom is 9,192,631,770 cycles per second. Wow, that's a lot. That's like 9 billion, I think. Some caesium clocks are accurate to 1 second in 15 million years. All right. And it has no known biological role. And it's low hazard. So that gets you through going forwards. Now, if you start coming back, you have 8.5. And 8.5 ends up being the atomic number for 5.8, excuse me. 5.8 is your atomic number for, and these are all atomic numbers, guys, for cerium, C-E-R-I-U-M, discovered in 1803 by Johns Jacob Berzelius and Wilhelm Hisinger. Cerium is named for the asteroid Sirius, which was in turn named after the Roman god of agriculture. All right. Cerium is a gray metal. It is little used because it tarnishes easily, reacts with water, and burns when heated. Cerium is the major component of metal alloys, just under 50%. The best known use for this alloy is in flints for cigarette lighters. This is because cerium will make sparks when struck. The only other element that does that is iron. Cerium-3 oxide has uses as a catalyst and is used inside walls of self-cleaning ovens to prevent buildup of cooking residues. It is used in catalytic converters. Cerium-3 oxide nanoparticles are being studied as an additive for diesel fuel to help it burn more completely and reduce exhaust emissions. It's a non-toxic compound that is rich red color. It's used as a pigment. And it's also used in flat screen TVs, low energy light bulbs, and floodlights. And then you move on and you got 1,7, which ends up being chlorine on the periodic table of elements. These are all periodic table of elements, and it was discovered in 1774 by Carl Wilhelm Scheele. Greenish yellow color. Let's see. Oh, the symbol shows a gas mask because chlorine is a toxic gas that has been used as a chemical weapon. Chlorine is yellow-green in color, as in the image. Appearance yellow-green, dense gas with a choking smell. Chlorine kills bacteria. It's a disinfectant. It is used to treat drinking water and swimming pool water. That's nice. I mean, think about that for a minute. It kills you, but it's toxic, but they put it in your water. Well, there's that. It also used to make hundreds of consumer products from paper to paints and textiles to insecticides. About 20% of chlorine produced is used to make PVC. Another use for chlorine is in organic chemistry. In the past, chlorine was commonly used to make chloroform, an anesthetic. However, both of these chemicals are now strictly controlled as they cause liver damage. Chlorine gas is itself very poisonous and was used as a chemical weapon during the First World War. All right. So then you're left with 5,9. And 5,9 ended up being praseodymium. Discovered in 1885 by Karl Auer von Welschbach. The name was derived from Greek meaning Paraseus Didymus, meaning green twin. All right. Green color. It's a soft silvery metal. I don't know what the symbol is. One commonly used for astrological birth of Gemini, the twins. Oh, the green color together with this symbol reflects the origin of the element's name. Got it. But it's a soft silvery metal, and it's used in a variety of alloys. To high-strength alloy, the high-strength alloy it forms with magnesium is used in aircraft engines. Along with other elements, it is, I can't pronounce, lanthanide elements. It is used in carbon arc electrodes for studio lighting and projection. The salts are used to color glasses, enamel glazes, and tints, and usually clean yellow. So the glass is used in goggles, used by welders, glass makers, because it filters out the yellow light and infrared heat radiation. It has no known biological role in low toxicity. All right. So that actually gets you through going forwards and backwards in atomic numbers for elements, chemicals, on the periodic table of elements, and I'll provide the links. And now we will move on to regular binary code within the coming days. And then move on to try to see what we can get out of those Bible changes. And I got asked what we can prove with this. Well, we can prove the pattern. As I've said before, we can definitely prove a pattern between the Mandela effect changes. The pattern can be argued as a coincidence, sure, but it's a provable pattern. Pattern's a mathematical concept. You can prove that, and we think that provides evidence for quantum computer use, which was a theory that was already out there. So yeah, I'll answer that question again in the video. I answered it too, but in the comments. But anyway, guys, that's it for this. Thanks for all your thumbs up, thumbs down. Thanks for all your comments, leads, feedback, and subscriptions. And thanks for watching, guys. And we'll get on to regular binary next in the coming days. And for now, you guys have a great rest of your day.